Welcome to this explainer. Today we are tackling a really fascinating paradox that exists in almost every single modern organization. How exactly do you manage the unmanageable? Think about it for a second. For over a century, management has been completely obsessed with standardization, efficiency, and predictability. But today, the absolute most valuable work being done in the world, things like creating artificial intelligence, discovering new biotech cures, building quantum computers, is entirely unpredictable. So how do we build a blueprint for innovation? How do we actually manage the brilliant knowledge workers whose very job is to break the rules and invent the future? Well, that is exactly what we are going to unpack today.
Okay, let's dive right into this. Here is the highly structured journey we'll be taking today. We're going to cover the baseline of traditional HR, compare the factory to the lab, explore exactly why R&D breaks all the rules, introduce modern HR solutions, look at some real-world applications, and finally, discuss the broader knowledge economy.
All right, starting things off with Section 1, the baseline.
So to really understand why managing innovation is just so incredibly hard, we first have to understand the foundation of traditional management. And at the core of that is job analysis. Basically, it's the systematic process of collecting information regarding the duties, responsibilities, skills, and competencies required for a particular job. This is the rigid bedrock of traditional human resources. It forms the basis for your job description, which is what you do, and your job specification, which is who can actually do it. In a traditional setting, this is a relatively straightforward, simple formula, right? You observe a task, you document it, and then you hire someone to repeat it.
Moving on to Section 2, the factory versus the lab.
Let's think about traditional factory work for a minute. Job analysis works beautifully in that environment because the work is routine, it's standardized, it's highly measurable, and it's driven by standard operating procedures, or SOPs. An assembly line worker in an automobile manufacturing plant is performing predefined operations over and over again. You can literally use a stopwatch and time motion studies to optimize the whole thing. But then, contrast that with research and development. R&D work is dynamic, it's innovative, fundamentally uncertain, and entirely knowledge-based. There is just massive friction between these two worlds. You simply cannot use a stopwatch from a factory to measure the mind of a scientist in a lab. It doesn't work. And this brilliantly illustrates that friction, especially when we start looking at output and performance. For a factory worker, their output is instantly quantifiable. You produced 100 units today? Great. But for a scientist or an engineer, the output is knowledge creation. Think about it. A scientist might work for 3 entire years before producing a single massive breakthrough. If you evaluate that scientist daily on just time and quantity, they're going to look incredibly unproductive right up until the exact moment they change the world. Performance in R&D relies heavily on creativity and innovation. Those are things that simply cannot be tracked on a daily quota sheet.
Which brings us to Section 3, why R&D breaks the rules. The constraints of managing R&D are immense. First off, the work is non-routine and highly uncertain. A scientist is solving unique problems every single day. There aren't any fixed procedures to just blindly follow. Second, as we mentioned, the output is incredibly difficult to measure quickly. Furthermore, we are dealing with rapid, unprecedented technological changes. Think about fields like AI, quantum computing, or biotechnology. The technology itself is redefining the work in real time, meaning a static job description becomes obsolete the very moment it gets printed. Finally, the work is highly interdisciplinary and team-based. Breakout innovations today emerge from collaborative teams mixing AI, electronics, and materials science together. That makes it almost impossible to isolate and measure just one individual's daily contribution.
Now, a real game-changing concept for understanding these constraints is something called tacit knowledge. Let's bust this piece of jargon real quick. Basically, this is the knowledge that exists strictly in a person's experience rather than in written manuals or SOPs. It's that gut intuition a senior engineer has about why a particular material is going to fail, even if all the math says it should work perfectly. Because it's experiential, it is incredibly difficult to capture during a traditional job analysis. The most valuable asset your R&D department has isn't the expensive equipment, it's the unwritten experience locked inside the heads of your team. The legendary management thinker Peter Drucker actually summed this up perfectly. He said, "Knowledge workers own the means of production, their knowledge." In a factory setting, the company owns the machines, right? But in an R&D lab, the workers own the critical machinery, and that machinery is their brains.
When they walk out the door at 5 p.m. to go home, the means of production literally leaves with them. This is a massive fundamental shift, and it requires a completely different approach to how we manage and retain talent.
So let's talk about solutions in Section 4, the modern HR solution.
So the crucial point is, if traditional job analysis completely fails here, how do we actually manage these seemingly unmanageable knowledge workers? Well, HR has to shift from just being personnel administrators to acting as strategic partners. Step 1 is competency mapping. Instead of listing fixed, daily tasks, HR needs to identify dynamic skills, things like learning agility, analytical ability, and problem solving. Next, they have to use flexible job descriptions. Instead of fixed responsibilities, roles are broadened so they can actually evolve right alongside the technology. And finally, performance has to move way beyond traditional KPIs. You replace those classic metrics with an innovation index. You're measuring patents, publications, knowledge sharing, and learning contributions. You are essentially measuring their capacity to grow and share, not just their daily output.
And to fuel all of those competencies, you absolutely must have this: psychological safety. This is a concept championed by Harvard's Amy Edmondson. Psychological safety is a culture where scientists are completely free to experiment without the paralyzing fear of failure. You see, in research, failure is practically a guarantee. Actually, failure generates incredibly valuable data. But if management punishes failure the same way a factory manager would punish a broken assembly line, it will instantly kill all creativity and risk-taking. Creating an environment that truly supports safe experimentation is a primary, absolutely crucial function of modern HR.
And right alongside building that safety, HR must fundamentally redesign how it rewards people. Because if you want innovation, you have to incentivize it properly. This means replacing standard corporate bonuses with patent incentives, providing internal research grants, handing out high-profile innovation awards, and heavily rewarding knowledge transfer mentoring. That last one? It's vital. Because of that tacit knowledge we talked about earlier, succession planning and mentoring are literally the only ways to ensure that when a brilliant senior scientist retires, their intellectual capital isn't just lost forever.
Let's look at how this plays out in Section 5, real-world application.
Let's ground these concepts and look at India's space and defense programs. We're talking about organizations like ISRO and DRDO. These teams are building reusable launch vehicles, human spaceflight projects, advanced drones, and entirely indigenous missile systems. You literally cannot hire for these roles using a rigid, factory-style job description. These massive projects require multidisciplinary scientists who might be doing fluid dynamics one month and then structural engineering the very next. They rely entirely on fluid, flexible, competency-based HR practices to manage engineers and scientists whose roles are constantly evolving just to meet the immense demands of the mission.
And we see the exact same thing with the India AI and national quantum missions. Quantum computing is a field that blends physics, mathematics, electronics, and computer science all together. AI is evolving so incredibly fast that a job description written in January is totally obsolete by June. Managing talent in these cutting-edge fields demands continuous reskilling, extremely dynamic competency mapping, and robust platforms for continuous learning. If these organizations don't adapt their HR strategies to be every bit as agile as the technology they're developing, they will fail. It's that simple. Bringing it all together now in Section 6, the knowledge economy.
Business strategist Gary Hamel famously noted, "Innovation is the key source of competitive advantage." And he hit the nail on the head. In the modern knowledge economy, your competitive edge doesn't come from how fast you can turn a wrench or run a machine. It comes from how effectively you can harness intellectual capital. Shifting away from that old factory-style management toward strategic, competency-based human resource management isn't just a nice, friendly thing to do for your employees. It is the very mechanism that allows modern companies to accelerate innovation and actually compete on a global scale.
Which leaves us with a final, pretty provocative thought to reflect on based on everything we've explored today. Take a good look at the structures, the job descriptions, and the performance metrics where you work. Ask yourself, is your workplace built for the assembly line, or is it truly built for the knowledge economy? Understanding that fundamental difference is the very first step toward unlocking real innovation. Thank you so much for joining me for this explainer, and I really hope this helps you see the invisible architecture of innovation just a little bit more clearly.